Hello everyone, good morning. Welcome to the class ECE451 Control Engineering. Today is the ECE451. Today is for the 11th week Wednesday's class. Oh, sorry. Turn around. Okay, 11. Alright. We already studied how to give feedback or the estimator for a system in state description, right? So, okay, the first one for feedback. It's a review. Feedback. We have x dot equal to ax plus bu, y equal to cx plus du. This is the plan. Suppose like a g of s, use g of s to denote. And then we can have a feedback r equal to u minus k kx. So this part we call the feedback from x is a full state feedback. Full state feedback. Then we know for any given list of poles, I say P. P is pole 1 until pole n. Choose k equal to, we have functions, Eckers function, right? We need a A, we need a B, and this P as input in this function. Then we have a k. You can also write the formula. This is a 0, 0, all of them are 0, only the last element is 1. Then times capital C inverse times A of A, right, where this capital C is B, A square B until A to the n minus 1 B, and as equal to s minus pole 1, that is as a poles, right? S minus pole 2 times until s minus pole n, and A of A is A of s, while replace s by A. Okay. So you can also calculate by this formula, or just use MATLAB. You can run this one. You can have k. Choose this k. Then y of s, this is output, over this input r. We'll have poles P1, P2 until Pn. Yeah, as you listed here. So this is for feedback. And we can have a structure. It looks like, okay, to simplify, I put G just one block, G of S. This is G of S. Then you can have output Y of T, and the input for this part is a U. And we use X for the feedback. X times k, negative k, and do a summation, and this side is r of t, right? Look like this. If here you put a k, here should be negative. You need to add a negative here, right? Okay. So this is for feedback. And then another thing is for the observer, or estimator or observer. Observer, you still have x dot equal to ax plus bu and y equal to cx plus du. This part is a plant. This is still plant, right? Plant. And we want to estimate. Estimate what? Estimate x. So here we will say, I put here, x unknown. We know u, y, they are known. We know them. And also a, b, c, d, we also have a, b, c, d. Right? We have all these. We know all of these. Just I don't know what is x. I just don't know what is x. Then we set the estimator. Set up an estimator. It's still use this one. It is a x bar dot equal to a x bar plus bu. I use same u, right? U is given, and the y now is y bar equal to c x bar plus du. All right. So this system, you see, it looks similar, almost the same. Just because when the system running, the initial values varies. So the x bar and this x, we don't know whether they are same or not. In most cases, they are not same. They are not same. Then I want to estimate x by x bar. Now how to do it? I need to check a difference between y and the y bar and add it here. I add the L times y minus y bar. Okay, I have these. So this estimator, it's run when it's run. It is not just run itself. It will run related with the original plant, right? Original plant g of s. It uses the output of this g as well as output of itself. Check the difference between them and use these as a kind of a feedback, right? This part is similar with u, but you can think we have u as input. We also have this as input. I have two input, right? Okay, I use this estimator. Then we can choose. L, so that the limit when t go to infinite, the x and x bar both are function of t. This one tend to be 0. Now we can have these. We can have these. Now how to choose it? How to choose it? I say this is a 1, this is a 2, 3, and a 4. How to choose? We consider 1 minus 2, 1 minus 3. 1 minus 3, we have x minus x bar, take derivative, equal to a times x minus x bar, right? And this cancel, and plus L times y minus y bar. And the second one minus the first one, we have y minus y bar equal to c times x minus x bar, and u cancel. So we can have x minus x bar derivative equal to a. Here's L times y, but y is c here, right? Sorry, I need a minus. 1 minus 3. C is subtract. So here's a minus L times this c, right? Y is c times x, so c, L times c, and here's x minus x bar. All right. So x minus x bar tend to be 0 when t go to infinite. If and only if I would say poles of a minus LC, they are on the left side left half plane. They are on the left half plane. In other words, is SI minus A minus LC. This one, determinant equal to 0, has roots on the left half plane. Okay, is this one. Okay, so we can use L equal to, I still use the Ecker function. Now is A with a transpose, C with a transpose, and the P is a list of the poles and a transpose. P are the poles. P choose poles. P equal to P1 to Pn. Then you can have L just like this. Alright, so this is estimator. This is estimator. This is estimator. And we can have a graph of it, the structure. I still use this. This is a G of S. Then we have a Y of T. Now we still have estimator writing this way. It's A, B, C, D, right? Something like this, right? This is A, B, C, D. I need this A, B, C, D. Like G is also A, B, C, D, right? Here is also A, B, C, D. But other than A, B, C, D, you have a Y, right? You have a Y bar output. Then you check the difference between the positive and minus. You have a difference. So this part, this will be Y times Y minus Y bar. You times L. You times L, and this L will come into here. Similar with BU, right? You have U. U go to here, also go to here, and also use L go to here. Things like that. Yeah, roughly you give the graph look like this. If you want more details, it works like this. You have 1 over S. This is X dot. This is X. Then for X, you need to go back. X dot is A times X plus B times U. Right, this is U. And Y will be C times X plus D times U. This is Y, right? This is Y of T. And we build a similar thing. This is a summation, this is a X bar, take derivative. 1 over S, and here's X bar. And I need a feedback. This is A. Okay, this feedback is a part of the system. And here's a C. Summation. Then I have Y bar of T. And here I need a B. I still need a U, right? I need a U times B. Go to here. If you want, you can also start from here. This way. Go to here. Then you can save one B here. Alright. I put a B here. And then I need a Y is a summation of this with a D. With a D. Right. I have Y bar. But then I need the difference between these two. This is positive, this is negative. This is a Y minus Y bar. And I times L. Times L. And L, then the summation will be go to here. Right, will go to here. It is a X bar dot equal to AX bar plus BU plus L times this difference between Y. Right? So L times difference between Y also go to X bar dot. So the structure will look like this. Right? Like this. And by this way, we can have x bar. I will say, if you want, you can have x bar here. X bar of t is close to x of t. Yeah, close to xt. So this is estimator. This part is estimator. Estimator. All right. This is estimator or observer. So by this one, you build this one, you can know what is x, right? You can know what is x. You cannot measure x directly. You only can measure y. Of course, you also can measure u. U is your input, right? You have y and u, but you build this part here, then you can know what is x. Of course, you need some time. When t large enough, they work very close. Right, so this is estimator. And for these two parts, the feedback, both feedback and estimator, we need this Ecker function, right? Ecker function, and actually we need a condition. We need a C. Here we need C inverse, and this one we need O. Yeah, I can write this formula. Arrow where arrow can be written as how to say, we need to reverse it, right? Reverse it. So one will be here, 0, 0, 1 will be here. Then here will be O with inverse, and his part will be A of A, let me see, transpose and transpose. Okay, just like this. Alright. And O, it is C, CA until CA to the N. Yeah, this one. Oh, this one. So we need this one inverse existed. So condition. That means we cannot always perform this kind of job here. You cannot always work like this. You need a condition only when determinant of this O do not equal to 0. In other words, that means system, the system G of S is observable. And another one, to get K in the feedback, in feedback design, we need condition. We need a condition determinant of that C do not equal to 0. Another word we call the system G of S is controllable. Alright, so we have it. Okay, this is for the single input, single output system. Actually, we can have similar work for multiple input and multiple output system. So for LIMO system, well, the formula will be more complex, so we will not go over it here in this course. But I want to explain something related with the controllable and observable for multiple input, multiple output. So in this case, for the controllable, we have C equal to B, A, B, A n minus B. This one. B will be not just one column. B has more than one column. More than one column, right? More, depending on how many input. How many input? Like a 2 input, there are 2 column. 3 input and 3 column. So this one is not a square matrix. C is not a square matrix. That means the formula like this one, we cannot have this one. No, for C will be another equation. For C, where I put it? Do I have that C term? Not this. That is here, right? For C is this one. C is this one. C is this one. Then I wanted the inverse, right? This inverse, of course, it only works for square matrix. So when C is not a square matrix, then you cannot have this formula. The Ecker formula, we do not have Ecker formula. Now we need to do more work to find the feedback law. But the idea should be similar. You know, ideas should be similar. Okay. But then for the controllable, we have different way for the controllable. We can consider the controllable for the controllable. We will consider for which input. Yeah, you have more than 2 input, right? More than 2 input. 2 or more input. You have 2 or more input. So for which input is controllable? For both or for just one? Right. Let me consider an example. I consider x dot equal to ax plus bu, where u equal to u1 and u2. Now I have 2 input. And A, I use a 3-dimensional. For example, I have -2, 0, 0, 0, -3, 1, 0, 0, -4. Suppose this is A. And the B, I need a 2 column. So I have 1, 0, 0, 1, 1, 1, 1. Okay, like this. This is B. Then what is this capital C? Capital C is B, A square B, right? Totally is 3 by 3. So here I need until A squared. Sorry. Then this one will be what? First is 2 columns are B, 1, 0, 0, 1, 1, 1. Right? This is B. Then A times B. A times B, I have -2, right? -2 and 1, 0, 0. And -2 is 1, 1, 1, still -2. And then 0, -3, 1. 0, -3, 1 is 0. 0, -3, 1. So it's -2. Right? Then 0, 0, -4 times 1, 0, 0. This is a 0. 0, 0, -4, -4. Right. Then next will be A squared times B. You can think it's A times AB. This is AB, right? AB. This is B. So A times this. So A times this, I get -2, and -2 is 4. Then 0, -3, 1. No. This one times this, and this one times this, right? Second column, still 4, right? And then 0, -4, -3, 1, 0, -3, 1, 0, -3, 1. Oh, it's a 0. Okay, then 0, -3, I get 6, right? -3, I get 6, and 1 times 4, so 6 minus 4, I get 2. And then 0, 0, -4 times this column, -2, 0, 0 as 0. 0, 0, -4, 0, 0, -4, okay, positive 16. Okay, I have this. This is A squared B. Alright, then we check the rank. we do not have the determinant, but we have the rank of the matrix. Rank of this C, do you know what is the rank? You check the I will say the maximum linear independent columns or linear independent rows. Actually, this will be 3. You pick some 3 columns. If you can find 3 columns which with determinant not equal to 0, then the order is 3. And here you can choose just the first column, second column, and the third column, right? You choose 3 columns. This one, 0, 0, 1, 0, 0, 1, 1, 1, and I choose this one, -2, -2, -4. The determinant of these were equal to determinant of 1, -2, 1, -4, right? You check this. It's 1 times this part, and this is a -4 plus 2 is -2, do not equal to 0. So we have a part of the whole matrix. Determinant is not 0, and this is 3 by 3. So the rank should be 3. The rank, yes, 3, because you only have 3 rows. So at most it is 3, and this one tells us it is 3. Right? It's larger than 3, and at most it's 3, so it's just 3. Okay, rank 3. So we say x dot equal to ax plus bu is controllable. It is controllable for all input. You need all the input. And if we only choose the first column, of B, that is 0, 1, 1, 0, 0. I say this is B1, this one. This according to you think second U2 is 0. You think second input is 0, right? The system AX plus BU is right, is x1 dot equal to A is -2 times x1 plus 0, 0, and plus U1 plus U2. And x2 dot is 0 plus -3 x2 and plus x3, and no U1 but 1 of U2, and x3 dot equal to 0, 0 plus minus 4 of x3 and plus 1 of U2, right? The system state equation just look like this. Now you think U2 is 0. U2 is 0. Then the system, you just remove them, right? Then in the control part, you have U1 times 1, 0, 0, right? 1, 0, 0. These two do not have U1. So it's 0 and 0, right? The first one you have U1. So 1 of U1. So you have B1 is like this. And by this B1, you can also have that capital C, right? For the case U2 is 0, you only use U1 to control the system. Then you have B1 and A B1, A square B1. You can check the stability for this one. Check the controllability by this one. This is actually just this part. I choose 1, 0, 0, the first column, right? And -2, 0, 0, and 4, 0, 0. Okay, so this one. So this one, the rank is 1 smaller than 3, or the determinant is 0. Determinant is 0. So uncontrollable. This one cannot be controlled. This one cannot be controlled. That means you cannot find the K to make the system assign some poles. Like you give some poles, you want to assign those poles and the system's poles, but you can't. No K can work like that. Things like this. Okay. But for B2, suppose if we let U1 is 0, then the system, that means B, we use B2. We use this, the B2, use the second column of B. Then we have B2, B8 B2, and 8 square B2. This one give us 1, 1, 1, negative 2. I just copy from here. Copy from here. I need these 3 columns, right? Negative 2, negative 2, negative 4, and 4 to 16. Okay. These 3 columns. And this one, the determinant should be not 0. Should be rank should be 3. We can check the determinant. Determinant equal to, this is a 2, negative 2 times 16, and minus 16, and minus 4, and plus 8, and plus another 8, and plus 32. So 32 cancel, 8, 8, 16 cancel, so this is negative 4, do not equal to 0. Okay. So this one, so that means for the controller U2, the system is controllable. If you just use U1 as a controller, it won't work. Right? You use U2. You use 2 as a control signal, then the system is controllable. Actually, we have example even for both single one, it doesn't work. It cannot be controlled. But when you combine these 2 together, it is controllable. Yeah, I can't find the example exactly right now. If you are interested, you can try. Yeah. Okay. Yeah, I leave it here. Okay. So for this kind of things, when you have 2 or more input, you want to check the stability, you still need to calculate these metrics. And for different input, like first input, you need this one. You need these 3 columns. This is for the first, for U1, for first controller. And this one, this one, this one, these 3, they are for second controller, control signal. You have U1 and U2, right? You check the stability, controllability for U1, you use these 3 columns. You check the controllability for U2, you use these 3 columns. Alright. Okay. This is the controllable and observer and feedback. Okay, now let's consider the combine of the thing like this. So this is it's also feedback. The feedback and the estimator. We combine these 2 together. You can think this is a feedback from the output Y. When we study feedback, we say that is a full state feedback. You use the feedback coming from the state. Now the things look like this. You have a plant G, which is matrix A, B, C, D. Right? This is a system. And then you have a Y of T as output. We use this Y of T, we give a feedback. Give a estimator. So estimator, I say it's a G bar of S. It is also use A, B, C, D. This estimator, and it will give us a Y bar. But Y bar, we will check the difference between Y and the Y bar. Then add the arrow here. Then okay, this one come into here, and U also come into here. This is a U. Yeah. So this is estimator. Okay. In this estimator, we can have x bar. X bar, it is close to x. Right? It's close to x. Okay. I use k, negative k here. Alright, so you see we put the feedback here. Then the system, you have a system, right? You just use y going to here. Then by a estimator you have a x bar, then estimator go to here times negative k, you can have the feedback. So this feedback you use y. You do not know what is x here, right? You can have an estimator of x, but you do not have x. You do not use x itself. You use an estimator of x. You estimate x and use this x as a feedback. Then you have a feedback. Okay, so yeah, nothing special, just like this. You know how it works in it. And also you should know how to choose L and how to choose K. The same way with the previous two steps. You use Ecker A and B and P for K. Right? K is this one. And for L, you use Ecker A with a transpose, C with a transpose, and okay, that will be might be different as for the Q, and then a transpose. Right, use this one. P, they are the poles of the whole system. And L, this one Q, they are poles for the how to say, for the arrow of the estimator. Okay, like this. So you can have the whole system. You have the whole system. Okay. All right. Is this good? This will be good, right? You have output, then you have the estimate of state, and you have the feedback. You do not know. You do not need to look inside what happened inside the plug. All right. So this is one thing. As for how to choose this P and Q, that depends your requirement. Like you want the maximum overshoot is how many, like 10%. Then you can choose a pole, right? Choose a pole, and according to that pole, you can find this K, right? And for this Q, you need actually this is chosen by you. You want the system converge fast or converge slow. You can choose different poles here, and you have error. Yeah. Usually you have if this one converge fast, then you need a large number. Error should be a large number. Yeah. So you are think about it for kind of a balance, right? Okay. This is feedback estimator. When you combine together, what will happen? And okay, the last thing here I want to discuss is a special case. A special case. Y is x1. Y is x1. We know this, right? For example, you have y2 prime plus 3y1 prime plus 4y equal to r. Then you let x1 is y, x2 is y prime. By this way, we can have the matrix form, right? Right. We do this a lot. And then we have y, it is just x1. Okay, in this case, for the estimator, let me see. We consider for estimator. For the estimator, we only need estimate x2 to xn, right? x1 is not necessary. The output is x1, so we already know x1. So we can change the estimator. You still can use the estimator we designed in this way, right? We still can use this error as an estimator. We can still design estimator like this way. But this way, when you work like this, you also need to estimate x1. And for the first shorter period when the system start running, x1 will be you will estimate, so you have error. The error might be big, but actually you already have y. So why do you do like this? You estimate x1, but x1 is not the accurate one. You already have accurate one, right? So in this case, we want the estimator which just estimate x2 to xn, and leave x1. It is just y, right? Okay. So the things like this. The plant, it is x dot equal to ax plus bu, right? But now I rewrite it. I use xa and xb, take derivative, equal to a b, bb times xa and xb. Actually, xa is just that x1, right? And the plus b is bb times u. And now y, it is just xa. And if you want write in matrix form, it will be 1 and then 0 to 0 times xa and xb. So here xa is 1 dimensional, and xb there will be n minus 1 dimensional, right? Got some cough. All right, this is system itself. Then we want estimate. So here we want to know the relation. We only need xb, right? So here xb derivative will equal to aba times xa plus abb xb, right? This is just the second row of the first part, right? This matrix way, I choose this row. So I have this one, and plus bb times u. We have this. This is equation xb will satisfy. We want to estimate xb from y. You can have u and y, right? You can have u and y. You want to estimate xb from y. But you see, y is what? Y is xa without xb. So it seems like it's hard to get information of xb from y, right? Y is just xa. But of course, xb still contain part of xa. This is y, right? xb contains some part of y. So it is related with y. So y will contain information of xb. But if we just use the previous way to estimate it, it makes things hard. So we can work like this. Consider we let z equal to xb minus ly. We work like this. Work like this. We combine xb and y together. Here I write minus. If you want, you put plus here. That will be also fine. But all the formula you will have sign different. Okay. Let z equal to this one. This is a new variable, new signal z. Z is xb minus ly. Then let's see what happened for this z. Z contain both XB and Ly, right? So we try to estimate Z, then go back, we can have XB. Then Z dot equal to XB dot minus Ly dot. And the Y dot is just XA dot, right? Y dot is just XA dot, XA dot, X derivative of XA. We have this formula. So we can plug in, we can have so we have Z dot equal to XB dot, XB dot is here. So this is A B A X A plus A B B X B plus B B U. Okay, this is XB dot, and minus L times Y dot. Y dot is just XA dot, right? XA dot is this line, right? So it is AAA times XA plus AAB times XB and plus BA times U. Now we have this. Then here I want to have Z itself. So Z is XB minus Y minus Ly, right? Also, this is also XB minus LXA, right? Okay, so these two. Alright, so this one equal to, I put this one and this one in the front. This is ABB minus no, let me see, I need to do something, and I want this one write it in terms of Z. So okay, like this, we have Z equal to, this is a XB minus Ly, so XB is Z plus Ly, right? Okay, I can plug in. So we can have Z dot equal to ABA times XA and plus ABB times XB is Z minus plus Ly, and plus BB times U, and minus LAAA times XA, and minus LAAB times XB is Z plus Ly, and L is minus LBA times U. Okay, then I do a simplify. These two are combined together. This is a, and I put these two firstly. These two, these are related with Z, right? So it is ABB minus L times AAB times Z. Alright, and then I have to term, these two term. Actually, this is related with Y, right? This is Y. I keep Y, I'll keep XA. It's the same thing. Okay, so it's plus ABA minus LAAA times Y. Yeah, this is Y. And okay, I used these two, and I need Ly terms and these terms. So the plus, okay, B minus LBA times U. I use these, and then these two terms. This is a plus ABB minus LAAB times Ly. Right? Okay, so we have equation looks like this. Okay, here, no, these two are same, right? This part is same. These two are same. Okay, so can I put them together? This is a ABB minus LAAB times z plus ly plus ABA minus LAAA times y, and plus BB minus LBA times u. Okay, we have this one. Did this work? Oh yeah, this works. This is just the XB, right? XB. So we have z dot equal to XB as ABB minus LAAB times XB, and plus ABA minus LAA times Y, and plus BB minus LBA times U. Alright, then we can build the structure, build the estimator based on this one. Now let's give the structure. You see, you have Y and U, right? The plant, you know what is U, what is Y. You can measure these two. And this one is a kind of estimator. You need to estimate this one. So things like this. I give the plant. The plant have G of S, which is given by A, B, C, D. Okay, this is the plant. Then you have output Y, and here it is a case. This is equal to XA of T. Okay. And this side is U of T as input. Then I have the U. Right? U times BB minus LBA, and Y, I need a Y times ABA minus LAAA. Right, so this one. I need these two. And need these two, and do a summation of these two. And this one plus x hat, that will be z dot, right? I have 1 over s is here. I use a z dot and z. Right, this is for z. And the input will be this one plus this one, and plus something from b. This b. B times, okay, yeah, b is here. And times BB minus LB, XB is time, not this one, sorry. It's ABB minus LAAB, and times this one. So here will be XB. Here will be XB. And the Z, okay, Z equal to XB minus LY, right? In other words, XB equal to Z plus LY. So this one plus LY. Y times L, go over L. We do a summation. This is just XB. This is just XB. I put a bar here. Alright. Yeah, it's estimate. Right? It's estimate. I replace this XB by XB bar. I want estimate. So it will be this one. It will be this one. Okay. So by this way we can estimate XB bar. Estimate this one. And the arrow of estimation. That will be X minus XB minus XB bar, right? So what is this one? We have Z. Yeah, we have this one, right? This is the. We have this one. This formula. This is, I say this is R formula R. And here I replace by X bar. That is a beta. We have beta, that is a Z dot equal to ABB minus LAAB times XB bar. This is estimate one, right? This is also Z bar. and plus ABA minus LAAA. This is y. Y is just y, not y bar, just y. And BB minus LBA times U. U is also just U. This is a beta. The alpha minus beta, it is a Z minus Z bar derivative equal to this one minus this one, right? So it is ABB minus LAAB times X minus X XB times minus XB bar. All right, and then I plus this one and this one are same. This one and this one are same. So okay, so we have these. We have these, and okay, Z bar. Z bar is XB bar minus LY, and Z is just XB minus LY. Right? We have these two. So Z minus Z bar, it is just XB minus XB bar. And this one is just this one. Okay, you see? So now we only need to assign poles for this one. So choose L equal to, I still use Ecker. Ecker with ABB. I need a transpose, right? The arrow in the front is transpose, and AB transpose, and those poles I put Q's and with a transpose. So we can find these error by this one. Okay. Then we have estimator. This is estimator. Just estimate X bar. Just estimate X bar. X bar B. Just estimate XB. And A is given. A, it is just Y. So you do not need to estimate it. Right? You already get it. Yeah. All right. Let me see. Okay. This will be all I want to give today. I have some more time, but that's all for today. So see you next time. And this is Wednesday, so there will be you will have a weekend. Actually, next week we'll prepare. The Monday was a review, and Wednesday for the last midterm exam. All right. Okay. Have a good weekend. Bye bye.